Okay, so we know the function y is e to the x. However, y e to the x also has an inverse function, and that inverse function is called ln x, or sometimes referred to as ln x. You can see it like here. So first things first, let's go about sketching the graph. So we know the graph for y is e to the x will look something like so. We know it's going to pass the y-intercept at 0, 1, and we also know that it has an asymptote at y is 0. Now remember, for an inverse function, all we need to do is reflect the graph in the line y is x. So if I was to sketch graph y is x and I reflect it, it will look something like this. And this is going to be the graph for the function y is ln x. Things to note are that now the asymptote is now at x is 0, and is now going to cross the x-axis at 1, 0. So those are just the key points that you need to know regarding this graph. Okay, so what is the ln x function? Well, basically, it's a log. We call it a natural log. The reason being is because ln x is equivalent to log x to the base e. So it's got a base e. In this case, we just reduce it, or we just call it a special name, ln or ln x. Now, these two functions, because they're inverses, they actually cancel out sometimes. And this is when. So if we have e to the power of ln x, or ln, and then inside e to the x, they cancel out to leave just x. Now, this is a very, very important characteristic that you guys have to be aware of. Let's look at this in a question. So if we have e to the x is 5, what we would normally do for exponentials, right, is change it to log. So we can say that it's equal to x is equal to log 5 to the base e. But remember, log with the base of e is the same thing as ln, right? So I can just say this is equal to ln 5 straight away. This ln function is actually in your calculator, so you can see it here. So all you need to do is press ln and then 5, and then you get the answer. But in most cases, they do want you to find the exact value, so you can just leave it as ln 5. Let's try another one. So if we have e to the 2x minus 1 is 10, then what I can do is now bring the power down, so 2x minus 1, and I can say that's equal to ln 10. Rearranging for x, I get x is equal to 1 plus ln 10 over 2. We can also do the reverse. So if we have ln 2x is 5, then we can change it back using e. So I can say e to the ln 2x is equal to e to the 5. In this case, the e and ln will cancel out, leaving me 2x is equal to e to the 5, x is equal to half e to the 5. Now, this second line of working, you don't really need to show. I'm just wrote it out for you just to show why or how this is happening. Let's try one more. So if we have 2 ln 3x is 10, first things first, we don't want any coefficient, or the coefficient of ln has to be 1, so we have to divide by 2 first. So ln 3x is 5, so therefore 3x is equal to e to the 5, x is a third of e to the 5. The final type of question is a continuation or a variation of one of the questions we did previously, and that's this one here. So it's in terms of e now. So what we should notice is we have e to the x, and we also have e to the minus x. So what I can do now is multiply every term by e to the x to get the equation e to the 2x minus 5e to the x plus 4 is 0. This is an example, or it looks like a quadratic, right? So we can factorize this with e to the x minus 4 and e to the x minus 1, and so therefore e to the x is either 4 or 1. We want x, right? So we should change it back, so we can say x is equal to ln 4 ln 1, and ln 1 is actually going to be equal to 0. So ln is just the inverse of the exponential function e to the x, and you just have to understand how we convert from one to the other.